¿Cómo es? Ah, Yoel Eche. Yoel, admit, and Eche, Andy. Andy. Hi, Manas. And Eche. Hello.
Hello.
How are you? Good morning.
Good morning. I'm fine. Hello.
Hi, how are you? Good morning.
I'm good. Hey.
Hello, everyone. Elif, Andy.
Hi.
I guess that you are the workshop leaders, no? Eche. Can you hear me? Hi.
Hi.
How are you?
I'm fine. How about you?
Very good. So, what is your workshop about?
So our workshop is about building competition robots, and we're gonna tell the steps of how to build a robot from nothing to building a complete robot.
Are you going to share your screen?
Yeah, I'm gonna share my screen.
Do you want to try?
Yeah, sure. Just a second. Okay.
Should I admit Yoel? He's part of your team.
Yeah.
I will admit it. Perfect. You can go to presentation, present.
Yeah. It's just, yeah. Can you see my screen right now?
Yes, and you click on present so that you can present. So, can you click on the, yeah, perfect. So I will, Manas will be your host. He's here to help you with anything you need. And I can also, now it's time, so I will admit all the participants.
Okay.
And yes, have a very, very good session.
Thank you.
Enjoy.
Hi. Would you like to wait for 2-3 minutes and then start?
Yeah, sure.
Sure. Yeah. Let's wait for everyone to come in and then we start.
Okay.
Hello.
Hello, everyone. We are going to take 2-3 minutes to start the presentation. Uh, uh, we are waiting for some other people to join in.
Okay.
Let's start in exactly 2 minutes.
Okay. Nasılsınız? Yoel'in görüntüsünü açmasını bekliyorum.
Araba değil mi?
Okay, maybe in the meanwhile, we can introduce each other. Who's gonna start?
Okay, I want to start. Okay. Hi, I am Sedat from Hisar School in Istanbul. I am head of the computer science department. We have tinkering club. We call them Idea Lab. Currently, we teach CS curriculum to high schoolers in extracurricular clubs. Let me share some of the finest ways teaching about the CS framework. Our students became more independent and peer learning became even more important as students and collaborated and interdisciplinary projects. The simple things means that students keep their focus on their vision for their project, and they see multiple aspects of development process, such as programming, electronics, 3D design, and development robotics. Now they are going to show and explain to us. Also, all my students here are my TA at the same time. And let's introduce themselves. Ece.
Hi, I'm Ece. I'm also from Istanbul, Turkey. I'm a student in Hisar School, and I'm going to be in 11th grade next year. I do programming and design, so that's all. Who wants to go next?
I can go next. Hi, I'm John. I'm going to be a 12th grader next year. So it's my final year in being physically in Hisar School. I mostly do 3D design and electronics, but I'm just starting out with programming as well.
I could continue. I'm Elif, and I'm from Hisar School as well. I'm going to be a 10th grader this year, and I'm more into physics and maths. So, yeah.
I'm Yoel. I'm also going to be a 12th grader next year, and I'm also interested in computer science and electrical circuits engineering.
Your sound seems to be a bit of an issue. Maybe you might try to sort of use headphones if you're not using. Try something else also. But in any case, you can fix it while we are in the workshop. Yes, Andy, please.
No sound.
No, it's cracking. Try speak something else.
Hi, can you hear me now?
Yeah, right.
Okay. I'm going to be a 10th grader next year, and I'm mainly focused on programming. And that's
Okay.
it.
Okay. So are we good to? I mean, like, oh, sorry. I need to tell you about myself as well. So I am Manas. I am from India, and I work with in education. I am an engineer, having worked in semiconductor industry for some time, and I used to make all those semiconductor chips, and also I am from electronics background. And in fact, I started my first project in college was in robotics. So it's a lot of nostalgia to meet you all. I hope and best wishes for your presentation to be good. Okay.
Thank
Anyone
you.
else want to introduce himself or herself? Anyone who has just joined? Okay, cool. So we start with the with the workshop. Sure.
Yeah, sure. So,
Okay.
Sedat, would you like to start?
I think you start, Ece.
Okay. Welcome to the Building a Modular Competition Robot for Beginners workshop. So like we mentioned before, we are from Istanbul, Turkey, and in a team called Hisar CS. So in this presentation, we're going to be talking about who we are, the powers competition, and the workshop structure, and then we're going to begin with building the robot.
So we are Hisar CS, and you might ask what's Hisar CS. Hisar CS is a group formed by the mentoring of the computer science department in Hisar School, which Mr. Sedat Yalcin is the head of. Including our graduates, Hisar CS grows bigger each day as new students coming to high school join. Since 2014, which is the opening year, Hisar CS has been organizing Hisar Coding Summit, a two-day event where Hisar CS students give free programming and design workshops to anyone willing to learn. And using the Raspberry Pi and other systems, we continue to make projects of our own as well and participate in different competitions. You can go to the next slide.
I did. Wait.
I think it got stuck. Our motto is make, fail, learn, repeat. We think that this way we can get further in our fields and the topics that we are trying to learn. And by the way, we are the place that we work in, which is called the Idea Lab. We are currently trying to make it into an official Fab Lab. So if anybody that can help with that is listening, it would be greatly appreciated.
So can you see the next slide?
We can see the power slide.
Okay, just a second. I think stop.
Okay. In the meanwhile, you can reach out to anyone here in Fab Lab and try to understand how can you graduate your lab to Fab Lab. I think you may find people in Fab Lab in this FabX Live, and you can ask them, any person from the staff. I mean, like just before Anastasia was here, and she can help you. She might help you on how to sort of graduate your lab to Fab Lab.
Okay, thank you.
Yeah.
So Powers is originally based competition in Cambridge University, and we've been attending as Hisar CS to the competition for several years now. And finally, in 2019, we organized Powers Turkey for the first time. and it's been a great success for us. We hosted many teams in our school, and we, different than the PyWorks UK, we gave workshops to the teams before the competition and provided them material kits, as you can see from the next slide. So that was like a really great experience for us, where we taught like the basics of building a robot. So as you might have seen the preparation for the workshop links, there were some things to like complete before the workshop, because like the time is limited. These were laser cutting the main chassis, getting the materials, soldering the motor driver, and 3D printing the parts. However, we understand that it might be difficult and you might not be able to complete the preparation. So that's not a problem. If that's the case, you can just listen and then watch the review again from the YouTube.
Can everybody that did all the preparation and gathering the materials write yes in the chat? Okay. About a little bit of the the workshop's course structure. Some parts of the workshop will be in video format, where we will open the videos that we prepared. Actual explanations will be in video, so that we could prepare better. But we will always be answering questions in the chat, and we will pause the video to answer the questions. So it will almost be like we are explaining it live. And we will also, we were also going to give a lot of time for the assembly as well, but I guess that time could be used for something else now.
So let's start building the robot. So Elif, if you can present your screen.
Yeah, sure. Okay, wait. Okay. So can you see the screen where I have my dimensions over here?
We can only see the video right now.
Okay. So here, I guess you can see the dimensions.
Yeah.
Yes.
Okay.
So now I want you to go ahead and take a picture of, or like screenshot of this, because like you may need it later on in case you can't catch up or stuck at a point. Okay, so now let's start with the video. Hello and welcome to the first part of how to build a modular competition robot for beginners by Hisar CS. Can you hear the sound?
Yeah, we can hear.
Okay. First, we're going to start with 3D designing parts of our robot. For that, I want you to open Fusion 360 software on your computer. It should look like this after you created your account. So first, I want to show you a demonstration of what we will design. Unfortunately, because of our limited time, we're not going to be able to build this entirely. But we will be able to design the motor mount you see over here and the chassis. So let's start with the motor mounts. I'm going to start with creating a sketch, which is a 2D drawing to define your design and be made 3D later on. To start our sketch, I select Create Sketch from the Create menu. Or you can just click on sketch item right above the create menu, right over here. Now I select which plane I want my sketch to be on, which is XZ for our case. As you can see from this bar, we're in the sketch mode. So our create menu has tools for sketch design, like this. I will first sketch the base, which is this part. So for that, I first need to draw a rectangle. So from the create menu, I go to rectangle, then to 2-point rectangle, or simply press R on my keyboard. Now my cursor has a cross attached to it. I click on the point I want my first corner to be, which is origin point for our case. Then I could have dragged my cursor to the second corner. But since we have exact measures for a rectangle, I will put those parameters in. The length will be 88 millimeters. Then I press the tab key on my keyboard to specify the width, which is 10 millimeters. And lastly, press enter to finish the rectangle. So it should look like this when you're done. Now we're gonna create another rectangle parallel to this one, which will represent this length over here. So I go to the create menu, select 2-point rectangle from there, and choose a random point on the edge of this rectangle to specify as my first point. It will have a length of 10 millimeters and a width of 4.375 millimeters. So I press tab and then write 4.375. And I'm done. So I put in the length value, then I press the tab key on my keyboard and then put the width. Well, I told you to create your rectangle at a random place. But on the motor mounts, as you see over here, their place is specified. To move our smaller rectangle over here to a specific place, we could go to the create menu and then sketch dimension, or simply press D on your keyboard. With this specific function, we can adjust the measurements of our sketch. I want my rectangle to be exactly 41 millimeters away from this corner. So I select this corner and drag my cursor to select this edge of my smaller rectangle and drag it along this way and hit enter.
Okay, so now I think you should be able to draw your sketch and do the things I did. If you have questions, ask them on the chat. And yeah, I want to give you some time to finish your sketch until this point.
If you downloaded and created a Fusion account, it would be great if you did it with the video. This video will also be available, I think, in the FabX Live YouTube channel. So if you don't have the materials or you don't have a Fusion account yet, you can follow along from there as well later.
Also, we're going to be posting all these videos into our website for this workshop. So you can also find the videos from there. Okay, so if you have any questions, please ask them in the chat. And if there is no question, we could continue, or you could say stop for another minute or something.
I think we continue. Elif.
Okay.
You can write in the chat, right? Participants can write in the chat.
Yeah, if you can't, you can just unmute yourself.
Okay, we can continue.
Okay.
Now it shows me the length between this rectangle and this corner. To adjust it, I double click on the dimension and enter whatever I want it to be, 41 millimeters for our case, and hit enter. Now I will draw another rectangle right behind this one, so it will be over here. This length will be 10 millimeters again. So I go to the create menu, rectangle, 2-point rectangle. This length will be 10 millimeters. Then I press tab on my keyboard and its width will be 3 millimeters and hit enter. So this rectangle will be right here, this part. It is drawn as another rectangle because it will be higher than the base, so its height will be different. Now we must do the same thing we did here for this side as well. But doing things over and over may be a very inefficient use of time. Fortunately, Fusion 360 has a great function to make things go faster. It's called mirror. Mirror tool requires a symmetry line from which it will reflect desired elements. I will create my symmetry line from the middle of this edge. So I select the line tool from the create menu and click on construction on my sketch palette. You don't really need to click on construction, but I use it because it separates what are the main parts of my sketch and which of them are parts that are only for constructing other elements. I drive my cursor to the edge. I drive my cursor across this edge and stop when I see a triangle or a delta sign right above my cursor. This shows that currently I am in the middle of the line I'm on. So I click on that point and drag the line all the way down to the parallel edge with 90 degrees and click again. Now that I have my mirror or symmetry line over here, I go to the create menu.
Okay, so here I guess you can draw your construction line, and then we're gonna move on to the mirror tool.
Is there a code behind? Can write in the chat or unmute themselves.
I guess there is no problem, so I'm gonna continue. Okay.
And select mirror tool from there. Now you see objects over here. It asks me what parts I want to reflect. So I choose every single line on this side. Let's make it a little bit bigger. After I selected all of them, I go ahead and click on where it writes mirror line and choose the construction line I drew earlier, this one. Now click OK, and we should get the rectangles right on this edge as well. As you may have noticed, our sketch looks a bit messy because of these constraints Fusion 360 adds as a default. To avoid this, we should simply uncheck the box where it says Show Constraints. And now they're gone.
Okay, so if anyone had any problem with the mirror tool, please unmute yourself or ask your question in the chat.
Okay, I have a question here. Although it might not be relevant here, but I want to ask Fusion 360. Have you made any comparison between Fusion 360 and SketchUp? And which one do you think that suits you best?
Well,
I can comment on that. SketchUp is generally used for like architecture, and sometimes the STL files that are exported aren't suitable for 3D printing. So for robotics, I think Fusion 360 is better. I'm not sure about, and also I'm not sure about SketchUp, but Fusion 360 is like a parametric modeling tool. So it has a timeline, and you can edit your past actions, and the design will update accordingly. So it's better for complicated designs.
Okay. Thank you.
Okay.
And another question is, while designing this, what steps are you taking to make sure that when you are 3D printing, 3D printed, it comes out smoothly? There is no glitches on the material part or any from design perspective.
So for all the holes that we are designing, we are making them a little bit larger to account for the plastic expanding when it cools down. And actually, Fusion does a really great job exporting bodies as STL files. So we don't have to do any sort of post-processing or STL optimization for the part.
Okay. Thank you.
Okay, so if there aren't any questions, we're gonna move on. Yeah, okay.
Now let's draw these holes on our sketch. Those ones. They will be part of the main elements on our sketch. So I click on the construction again to deactivate the construction mode. So then we go to the create menu, circle, and 2-point circle. 2-point circle will allow us to choose a point on a diameter of the circle we want to draw and its diameter. Hence, I click on a random point on our construction line. So maybe over here. And drag my cursor, then specify my circle's diameter, which is exactly 3.3 millimeters. Then I hit enter. Then from the create menu again, I go to sketch dimension or simply press D on my keyboard. This way I can determine the distance between this edge and the center of my circle. I click on the circle, then on the line, and drag my cursor to see the distance between them. Now I can alter it by double-clicking on the value to exactly 5 millimeters. Well, we need the same circle for the other side as well, right?
So I guess you can guess which tool we're gonna use. It would be great if you could write it in the chat box. So we need the same circle on the other side as well, with the same diameter and measures.
Any guesses?
Yeah, that's correct.
It's the correct tool, yes.
Okay. So let's continue. Yeah.
Hence, we can use the mirror tool again. I select the line from the create menu, then activate the construction mode and drag my cursor on this edge and stop when I see the delta or triangle sign above my cursor, which means I'm in the middle of this edge. So I click on that point and drag the line until it reaches this edge, and click again. So now I have my symmetry line or mirror line. After, I go to the Create menu, select Mirror from there. And as objects, I select my freshly made circle. And as mirror line, I choose this construction line we made earlier. And hit OK. When I hit OK, it should look just like this. Now we're done with our base, so we can click on Finish Sketch over here on the upper right corner.
Okay, so did anyone have any problem? It can be about the previous tools or the last one we did, the mirror tool.
Before we move to the next part of the video, everybody should be complete with the sketch part since we are going to the 3D modeling part. So if everybody is okay, you can write your question or write okay in the chat.
Okay, we can continue. Okay.
After those, we're done with our sketch and can start making it three-dimensional. For this, from the Create menu, I will use the Extrude command, or you can simply hit E on your keyboard. I will select the parts I want to extrude, which are these. This one, and this one. To select more than one part, I constantly press on Shift on my keyboard and click on those parts. I don't select the circles over here because I want them to be holes in my design, like in this one. So as you can see here, Fusion 360 wants me to report the height, and that is 4 millimeters for our motor mounts. Then if I hit enter, I should have a three-dimensional part just like this. You can view it or see that it's three-dimensional using the view cube right about here. Well, I didn't extrude the smaller parts over here, right? That is because they will have a different height measurement because they represent these heights. But now I can't see my sketch anymore. To solve that,
did anyone have any problem with the extrude command, or if you have any questions about any part, you can ask now. You can unmute yourself or use the chat box. Okay, so I'm gonna continue.
I click on the tiny arrow near the sketches menu and unhide my sketch. So I can see my sketch right now. Now I can extrude those parts. So I go to the Create menu and click on Extrude or hit E on my keyboard such that they will have a height of 28.26 millimeters. Then I hit enter. Lastly, we should add the holes on these parts, these holes. To do that, we go to the Create menu and create another sketch. For my plane, I select the sides that are looking outside over here, so my sketch will now be on this surface. Then I go to the Create menu and select the Line tool and click on Construction, because this one will not be a major part of my design. I will drag my cursor along this side until I see the delta or triangle sign above my cursor, which means I'm in the middle of this edge. Then I drag the line for 5.05 millimeters and hit enter. Then I go to the create menu, circle, and 2-point circle, and deactivate the construction mode. I click on where I left my construction line and specify my diameter as 3.3 millimeters. Then for the hole above, I go to the create menu and select the line tool again as a construction line. So I activate the construction mode and drag my cursor along this edge until I see the delta or triangle sign. Click on this point and drag my cursor and specify this length as 2.112 millimeters and hit enter. Then from the create menu, I go to the circle and 2-point circle. I deactivate the construction mode again and select my first point as this point where I finished my construction line. Click on that point and then I specify my diameter as 3.3 millimeters, just like the last one, and hit enter. And as we're done with this sketch as well, I can now click on the finished sketch on the upper right corner over here. Then I go to the create menu and then extrude, or simply press E on my keyboard and select those circles while pressing shift. Well, extrude doesn't only help us create material, but we can use it to cut or remove material as well. On the extrude menu over here, you can see the part where it writes operation. I change the operation from new body to cut, so that when I extrude my sketch, it will remove material wherever it intersects with one. So I extrude it, see here. So I extrude it on cut operation all the way back until I get those holes on the other side as well. Then I hit OK. When you're finished, it should look just like this. So this way we created our motor mounts and can move on designing the chassis.
Okay, so this part was about designing the motor mounts. If you have any questions, again, you can ask them in the chat box. Now I'm going to stop sharing and let Ece present her screen. So just a second. Okay, so can you see my screen?
Yes.
Okay.
Now we finished designing the.
Can you hear it? Yes, we can. So again, if you have any questions during the video, you can ask through the chat.
Motor mount, and we're gonna move on with the chassis, with the frame. As you can see from the complete design, the chassis holds every other part of the robot. And we're gonna attach the motor mount and the camera mount to the frame. So now we have our motor mount on our screen. We're not gonna use that for a little while. So to start designing the frame,
I think there's a problem with the sound.
Wait, let's try again.
It comes from the speaker, so you have to unmute yourself. I think that's the issue.
I have to catch up or just
Can you hear now?
check
Can you hear now?
what you have done. You can use the image on the right. So now we first have to create a rectangle. For that, we're gonna go to the rectangle tool, 2-point rectangle tool on top. So click, and then we're gonna write the dimensions, which are for the short side, 116.75. For the long side, gonna be 150.93. And then we're gonna click enter. So now we have a rectangle. We just clicked the 2-point rectangle, created a rectangle using these dimensions. Now, as you can see, as you can see from the image on the right, there are arcs on the front of the frame. For that, we're gonna go to the Create menu. For that, we're gonna go to the Modify menu and then click Fillet. Fillet just puts an arc to the area that we chose. So now we're gonna select 2 lines, and it automatically creates. We're gonna write 40 for the radius, and then click enter. We're gonna do the same thing for the other side. So go to Modify menu, click Fillet, choose the sides, and write 40.
So is everyone okay until this point? Are there any problems? I guess not, so just a second.
Is everybody okay? Okay, you can continue.
Wait, there's a problem with the screen.
Now we finished design.
Can you see it?
Yes, we can. It's great, yeah.
Radius, and then click enter. We're gonna do the same thing for the other side. So go to Modify menu, click Fillet, choose the sides, and write 40. So now we have our basic shape. Now we're gonna do the holes. So for the holes on both sides, not on the front, we're gonna use the motor mount to place the holes on the right place. For that, we're gonna first click Finish Sketch, and then we're gonna click on our sketch, click Extrude, and then turn the sketch into a 3D shape. It's gonna be 3 millimeters. So we're gonna write 3. So now we have the 3D shape of our chassis. So now we're gonna move the motor mount to here and then create the holes. So first we have to select the motor mount. You can simply click the name of the motor mount from the menu on the left. So it's body 20 for me, but the name is different for everyone. So I'm clicking body 20 here, and then I can right click and then select move/copy, or I can click M on my keyboard. So now we just want to move this to right here. So for this, point-to-point move type is really useful. So I'm just gonna click point-to-point from here, and then select the point on the motor mount that I wanna move. So it's gonna be this. The first points will be on the motor mount because we're gonna move the motor mount, not the chassis. So I'm selecting the points, and then I'm gonna select this point as my second point. So as you can see, it just moved to where I wanted, and then I'm gonna click OK. So now we can create a copy of motor mount to do the same thing for the other side. We have to select the complete motor mount shape again. So I'm just gonna click body 20 here. I can do Command C or Control C to create a copy, or I can right click and then select Move/Copy and then check the Create a Copy box. I'm just gonna do Command C and Command V. So now I have I have the second motor mount, and I'm gonna just move it. And again, we're gonna do point to point. So first we're selecting the points on the motor mount and then the chassis. So now we have it. The next thing is creating the holes. So we're gonna create the holes on the chassis and chassis. For that, we're gonna click Create a Sketch and then select the plane. Now we're gonna go to the Create menu and then click Project/Include and then click Project. So we're clicking Project, and then it wants us to click a shape, a geometry. For that, we're gonna select this circle and the other circles, but be careful to select just the circle, not the shapes, not the other surrounding shapes. So we're selecting all the circles. As you can see, we have 4 selected shapes, and then we're gonna say, okay. So now we have the circles as a sketch. The only thing we have to do is first click Finish Sketch, and then we're just gonna extrude the sketches. So click Extrude on the top menu, and then we're gonna select all the circles.
I want to come in here to ask a question. This shows sketches, so there is an enumeration of a lot of sketches, like 1 to 19. So what are these here?
Can you ask the question again? I couldn't.
Yes, you say that those holes, 4 holes become 4 sketches, right? So I'm asking that why is it showing 19 sketches in this design? Are there 19 sketches in this design?
Yeah, so this project that I'm designing on has more sketches because that's where the complete design is, but that's not what we like. It's not something important that you should like worry about.
Sure. Okay. I'm just trying to understand the software.
It includes the other parts as well.
Okay, let's continue.
After we selected all the circles, we're gonna use this arrow to pull the sketches down to create a hole. And then we're gonna click Enter. So now we have 4 holes aligned with the holes on the motor mount. So now we're gonna create the last 2 holes to finish the design. For that, we're gonna go to Create Sketch again and choose the plane. So, so the only thing that matters in terms of dimensions is the length between the 2 holes. So first we're gonna create a circle. It doesn't matter where you create the circle. The diameter will be 4 millimeters. And now I'm just gonna create a line from the sketch menu to see the length between the holes. I'm gonna do 39 and then click enter again. So we're gonna create one more circle with 4 millimeters of diameter and then press enter. So we have the circles here. We're not gonna use the line anymore. It was just to measure the length. And then we're gonna click finish sketch. So we can delete the line. Now we have to select the circles, to extrude them and create a hole. So we're gonna select the circle. After we click the extrude on the menu, and then we're just gonna pull the arrow. And now we have 2 holes for the camera mount. So this is what the design should look like at the end. We can also change the color of the parts by right-clicking and then selecting appearance. And then we can make it whichever color we want. To print our design, we have to move the motor mounts away from the chassis to print properly. So we can just, don't forget to click, select the first free move type to move the shape, move the body. So you can just move it like this and then send our design to the 3D printer.
Okay, so that was it. Are there any questions about the 3D designs? Okay, then we can continue with electronics. John, you can share your screen.
I'm not a co-host, so I can't share my screen right now.
Okay, I make you the co-host. Just wait.
Okay.
Now you can share the.
Not this one. So now that we are done with the first part of our robot, which was the 3D design, we can now move on to the electronics.
John,
So the brain.
John, we can't see the video.
Okay, 1 second.
Try sharing another screen.
Is it okay now?
Yes.
Yeah.
So now that we are done with the first part of our robot, which was the 3D design, we can now move on to the electronics. So the main brain of our robot will consist of a Raspberry Pi 3B+, which can be seen here. So the way we are going to use the Raspberry Pi is via these pins here, which lets it interact with different sensors and electronic modules so that it can interact with the real world. We've included the pin layout of the Raspberry Pi here. In our robot, we are going to use these 5-volt pins, a ground pin. You can use whichever one you want, and a few GPIO pins. GPIO stands for General Purpose Input Output. So it can be configured either as an input or an output pin. As an output pin, it can output a voltage of 3.3 volts. and as an input pin, it can receive voltage from different sensors, so the robot can interact with the real world. We will also use a breadboard, which is a very useful tool to prototype with electronics without being bothered with all the soldering and desoldering. The breadboard that we included in the materials list only has these horizontal connected pins, which are connected via like this yellow and green lines are shown. They are connected with these 5 pins are connected with a metal plate under the pins. And if you have a breadboard with these plus and minus parts, they are connected vertically. So all these minus pins are connected like this, as my pointer shows, and the plus or power pins are shown like this. These are so that you can plug the 5-volt and the ground pins to the designated slots, and you don't have to always connect different 5-volt and ground pins to these pins. You can just use these for connecting the GPIO pins or the signal pins. Since using a breadboard is really important, I want to clarify a few things. The horizontal connections in the middle are always perpendicular to the spacing in the middle of the breadboard. So a wire that you connected to E1 will be connected to A1. So that's basically how you use a breadboard. The second most important piece that we are going to use is this part, which is the motor driver, more specifically DRV 8835 DC motor driver for the Raspberry Pi. It has 6 screw terminals as shown here. These 2 are for the motors, and this one is for powering the motors. In the materials list, we the camera, we didn't include the camera in the parts list, since we are not going to show how to program it in this tutorial, but the servo and ultrasonic sensor mount included in the parts list, you can also add a camera to it as well if you want. We brought a library, so it's really easy to connect the camera as well. We didn't have enough time to show how to do that in this workshop. Included a stackable header, which has longer pins than the one included with the original motor driver, so that you can connect different sensors as well as the motor driver. This driver doesn't use all the pins on the Raspberry Pi, it just plugs in like this. Which wire you plug it in here doesn't really matter, since these are omnidirectional DC motors. You can plug in either wire and it will just change the direction of rotation. But of course, the power pins matter. The rightmost pin that you see is for the voltage pin, and the pin next to it is the ground pin. This battery pack will be a 9-volt battery in our robot. This part here is a special voltage regulator for this motor driver, so that you can power the Raspberry Pi and the motors from the battery pack. We didn't include this one since our 9-volt battery can't handle powering the Raspberry Pi and the motors together. So we will just power the Raspberry Pi with the micro USB port and the power bank. The distance sensor we are going to use is HSR04 ultrasonic distance sensor. So the working principle of the sensor is similar to the echolocation in bats, as in it sends a sound wave and uses the time it takes for the sound wave to get back to the sensor to understand how far a wall or an obstacle is from the robot. So it has two speakers and vibration sensors like this. The one marked with T is the transmitter, and the one marked with R is the receiver. So the transmitter sends the sound wave, and the receiver receives it. The sensor transfers that time data to the Raspberry Pi. It's 4 pins. The one marked with VCC is the 5-volt input pin. So you have to connect it to the 5-volt pins on the Raspberry Pi. The trig pin is the input pin, which will be plugged into one of the GPIO pins. And that GPIO pin has to be configured as an output pin. We will show that in the programming part. So that it can send data to the sensor as to when to send the sound wave. The echo pin is the output pin, and this will also be plugged into another GPIO pin. And this gives the Raspberry Pi the time data that we are going to use to calculate the distance between the sensor and the obstacle. And the ground pin, GND pin, is connected to ground, or sometimes it's marked at 0 volts. But in so the trig pin is the input pin of the ultrasonic sensor. So the GPIO pin that we connected has to be configured as output. So it sends data, sends voltage to the ultrasonic sensor. And the one marked with output pin here has to be configured as an input pin on the Raspberry Pi.
Pin layout we showed, it was marked as ground or GND. And we are also going to use this servo motor, which is just a geared DC motor with a potentiometer inside. It can only turn 180 degrees, and you can control the rotation angle really precisely. This has 3 pins, a VCC, which is 5-volt input, ground, and a signal pin. This signal pin will be connected to a GPIO pin configured as output in the later part of the workshop. So we included this like connecting diagram with a breadboard. If you don't have the motor driver, or you didn't solder the longer pins to it, you can make these connections, try these sensors out, and try the motor driver separately. But to use them together, you have to use the longer pins. The motor driver doesn't all the pins in the Raspberry, but you can't plug these in if the motor mount is on the Raspberry Pi. So longer pins are necessary. Now,
if you don't have the stackable header for the DRV motor driver, you can just make these connections first, then just try these two together, and try the motor driver separately, since you can't connect them together. And now you can just take a screenshot, or we can wait for you to do the connections. Which one would you prefer? I can't see the chat, so. Okay, if everybody took a photo, I will now move on to the like the basic assembly instructions of the robot, and we will move to the programming part. So as you saw, 1 second. Can you see my screen?
Yes, we can. Yeah.
Okay, because it says pause. So as you've shown before, this is the complete robot. We didn't include the power bank in this, since we didn't know which specific power bank you were going to get. But basically, with the longer entry screws, you have to screw in the yellow DC motors to the laser cut chassis, and with the shorter entry screws, you have to screw the motor mounts on the chassis and do the same thing on this side. So the reason to include the Velcro strips in the material list was that since this robot was originally designed for like a really large group workshop, we wanted to make it as modular as possible and easy to assemble as possible. So using the Velcro strips, you can put the power bank and the Raspberry Pi and this front assembly wherever on the robot you want. You can put the ball caster wheel like this. If you have a different ball caster, by the way, you can just edit the design and cut the chassis again.
Okay.
Now we can move on to the programming part.
Then I should share my screen. Okay. Can you guys see it?
Yeah.
Yes, I'm there.
Okay. Is there sound?
No sound.
No.
Wait a second.
If you have the file on your computer, maybe you can open it that way.
That's where I'm playing it from. Well, then should wait a few seconds before I do this because it worked beforehand. I don't know why it's not working right now.
While you are starting to share the video, you can check the share computer sound on the lower left side.
Where do I do that? In the microphone section?
No, when you press share screen, it's at the lower left hand corner.
Share computer section.
Maybe that would work.
Of RasPi. Start looking at programming. Set max, okay. Hope you can hear it because it's a little bit low. To start looking at programming, we need to familiarize ourselves with some of the tools that we're going to be using today. Beginning with the navigation of RasPi. So first, you can go to the preferences menu to edit your configurations to, can you hear it?
Yes.
Yes.
Suit your Wi-Fi country needs, or maybe edit some of the mouse and keyboard settings. After that, go and open the terminal. To open the terminal, you can go under Accessories and Terminal, or just press the shortcut button here. After that, you're going to have to open the idle through the Raspberry Pi icon again, Programming, and Python 3 idle. It will start with the shell, Well, after going File and then New File, you're going to be able to open up this menu where you can write your piece of code. After that, let's go to our repository, the Pi20 English repository. I'm going to be using this repository. It is the English version of our PyWorks Turkey library that we have used in our competitions to teach the kids an easier way and a more convenient way of programming these robots. So, before you install it, you need to install these dependencies, which are required libraries that our own library use. And to do that, you need to copy and paste these codes one by one into your terminal. Paste the code in. So I paste it here, and as you can see, the code is copied and pasted onto the terminal. You have to do these each one by one, and after you've done that, you have two options: either pip3 install Pi20 English, or you can clone it through Git and then install the setup.py. Although I would recommend you use pip since it's more convenient and easier and has less errors. Okay, that was the first video. Do we have any questions? Okay, I guess I'm going to continue. It's another video. It's going to be... Controller class functions in Pi20 English. First, we have the initialization. In this part, we're going to initialize Pygame, which is a library that you use and need to install as your dependency. After that, we're going to initiate a Pygame joystick object. And then, we're going to make an array or a list called buttons, which will store our button inputs. I'm going to make left x left y and right x right y. These will be our inputs from the sticks on the controller. After that, I'm going to make a method called start taking inputs. This will create a thread where it's going to run the refresh method, and then it's going to stop running by returning self. After that, we have the refresh method. In the refresh method, we have a while loop. In this while loop, it will detect your inputs from either your controller joysticks or buttons, the face buttons to be exact. So in these lines here, the joy button down and the joy button up are inputs from the buttons, and these will basically append the input of which button was pressed into the buttons array, which you can return from the methods down here. And the same goes for the axis motions, which read the value from the left sticks x-axis, left sticks y-axis, right sticks x-axis, and right sticks y-axis. After that, we have these methods which return the values that are gotten from the refresh method. In these methods, you can it will return either sticks values, the buttons array, or the other right or left sticks values. You can call these in your code to return the inputs that are made from the controller. Okay, so in this part, I'm just going to say that, well, these are just explanations of how the library works, and after these, we're going to get to how they can be used to make a piece of code that you can manually control your robot with a controller. And, well, I need to say that for this Pygame controller code to work, you need to either connect your controller through the USB port or Bluetooth. Okay, and Let me just go share something else to another video.
Can I add a quick bit before we move on to the next video?
Yes.
We made this library. We made this library for like the participants of the PyWars Turkey workshop and the competition. But anybody can use it. It's on our GitHub. We have it on our website, and we show that end as well. It's like it's to make getting into robotics easier. So maybe if you or anybody that you know wants to get into robotics easily, they can start up with this library maybe.
Let's look at how the motor control class works in the Py20 English library. We start with the initialization. In this method, we set two class variables, right speed and left speed, and set them to 0. After that, we have the adjust speed method. In this method, there are two parameters, right speed and left speed, which are then set equal to the class variables right speed and left speed. Then we have four if clauses. In these clauses, if the right speed exceeds 480, then the right speed will be set to 480, and if it exceeds minus 480 or is actually less than minus 480, then the right speed will be set to minus 480. The same goes for left speed as well. After that, the motors are set to speeds right speed and left speed, and this method and this motors actually class is taken from Pololu DRV8835 RPA library. After that, we have the change controller value to motor value method. Here you can get the math of the method. Now, for the change control value to motor value method, I'm not really sure if I can explain it right now since we don't really have a lot of time. And also I'm not the one who programmed that method. Actually, we have multiple people that contributed to this project, and maybe I can ask them to give a more or actually a better way of explaining this stuff, since I don't really know the mathematics behind it. Anyway, I'm going to move on to the part where we are actually programming using the library. So let me just open that video real quick. And share that. Okay. And let's look at how a controller controls motor scheme would work using the Py20 library. So first, I'm going to start by importing a library, which is Py20 English. After that, I'm going to initiate our motor object, which would be motors, and then I would say Py20 English dot motor control. After that, we need to make our controller object, so I'm going to type it by saying joystick. This would be English dot controller. After initiating the joystick object, I'm going to start reading inputs. To do that, I need to type start taking inputs and run this method. After that, I'm going to make a while loop where we will be taking our inputs, which are going to use the left joystick on the controller. I'm going to call these values LX and LY. So that would be joystick dot read left values. Then I'm going to make the right speed and the left speed variables for the motors. To translate the values from the controller to the motor values, we're going to use this method in the motors object called change controller value to motor value. It's a pretty long method, and we're going to type in the parameters Lx and Ly. These are the inputs that we're going to want to change to motor values. After that, I'm going to say motors dot adjust speed, and I'm going to enter right speed and left speed. And this is just the basic piece of motor or controller controlled motors. You can run this code through the terminal by typing, for example, sudo python 3 controller test.py, or the name you named the script after. As you can see, in only a few lines, we have written a code that you can control your robot using a controller. When using this library, it's actually pretty simple to code this stuff. And well, if there aren't any questions, then I'm going to move on to using ultrasonic sensors. Should I move on?
Yes, yes. And
okay. Then I'm going to look at the ultrasonic explanation. Let's take a look at how the ultrasonic sensor class works in Python English. First, we start with the initialization. We have a few parameters here, being echo, trig, and the setup. First, we start by making a time, which is equal to 0, and then we make the current value, which is 0 as well. Then, we set up the GPIO with the setup parameter, which is automatically bored. After that, we set up the pins as trig for output and echo for input. Then we say that the output on the trig pin is false, since we're not outputting anything from trig right now. After that, we have the start measuring distance method. In this method, we open a thread which runs the measure distance method and then waits with the sleep function. After that, we have the read distance method, which returns the current value which is stored in the class. After that, we have the measure distance method. In this method, there's a while loop, and inside the while loop, you can see that first we make an output from the trig. It waits for a few milliseconds, and after that, we close the output from the trig. In this time, we have a signal beginning time, which we record as time, which we record as signal beginning. After that, we make another while loop, which in this case is that when the echo part of the ultrasonic sensor is receiving an input from the trig output, and if that happens, then the signal end will be recorded as time, and I'm going to make the calculation. The time is equal to the end signal and its beginning signal times, and after that subtractions happens, we're going to see that the current value is equal to time multiplied by 1750. We multiplied by this value because the speed of sound at sea travels at 300 centimeters a second, and in our case, since distance is equal to speed times time over 2, the distance will be calculated as 1750 times the time, which in this case the unit is centimeters. By the way, for those who haven't used the RPI.GPIO library before, the GPIO.board here means that the pins, which are the echo and trig pins, are actually the physical pin number on the Raspberry Pi. So, for example, the top pins are 1, 2, 1, 3, 5, and the bottom pins are 2, 4, 6, and so on. And finally, I have the video of using this class. Let's take a look. Let's take a look at how a student might write some code based on the ultrasonic sensor. I'm going to be writing an automation code for distance detecting and motors. Let's start by importing our library. To do that, we're going to type import i20 English. After that, we're going to create our motor and ultrasonic object. So first, let's create our motor object by saying English dot motor control. After that, let's make our ultrasonic object. And we're going to tell our trig and echo pins. So trig is 38 and echo is 40 in this case. I made an error here, so this actually is the echo pin and this is the trig pin, as you might have seen from the class explanation. And then let's say that start measuring distance. This will create a while loop which we can use to run functions like reading distance. To do that, we're going to make our own while loop in this code and then type distance is equal to read distance. So this will continually get the distance values from the ultrasonic sensor. After that, we're going to print the distance to see the output, and then we're going to create an if clause and say, like, for example, if distance is less than or equal to 100, it would be 100 centimeters, the motors would have to stop. So motor dot adjust speed to 0 and 0 for both motors, and else, which in this case will be bigger than 100, say they should go at max speed, which would be 480 and 480. After that, you can save this code and then don't forget to run it through the terminal by saying, for example, sudo python 3, and in this case maybe it would be like ultra test.py. Press enter and run your code. And well, that was it.
Okay, thank you, and it's great. Okay, guys, Elif, Can, can you give us some example or tips and tricks after this workshop? What can we do or something like that?
So, as you guys know, the robot that we are building is like a modular competition robot. So you can first of all buy a Pi camera and do different things with image processing, and you can build upon the basic design of the robot and learn along the way. I also want to show you some few frames from our actual Pi Wars competition. 1 second. So this is like the recap video for the Pi Wars Turkey workshop, which was 2 days long. By the way, 1 second. This means see you, if you are wondering. And this is like the recap video of our workshop. By the way, the competition. By the way, this event was 1 or 2 weeks before the first case of coronavirus happened in Turkey, so we were like really lucky.
I think Elif, if you want to share, because the internet problems have it, John.
Okay, I can share as well. Wait a minute. Yeah. Can you see my screen?
Yes, yes. And sound, please.
Can increase the sound.
Before the workshop, lots of students don't have any idea or any knowledge about the robotics, right? John, Andy.
They learn everything from scratch most of the time.
Yeah, we made the workshop as like a starter for them and gave them like a 1 month long build season. So everything that you, like every robot that you see in this video, they built it in like a month from scratch.
By the way, all of the map or we create that, right?
Yeah, all the like challenge areas and like the maps we created.
Okay, so let's continue. Yeah.
Okay.
That's it. And we also have a website.
Full screen real quick without if you want to see like the unlaggy version of this video, or you like the workshop, you can subscribe to our YouTube channel, which is Hisar CS. You can show our channel name, Elif.
Okay.
It has like all the workshops, trailers that we do.
Okay.
Yeah.
Thank you, guys.
Okay. Wonderful effort by you guys, especially you being everyone, including everyone, and sort of learning together and presenting. It takes a lot of effort and logistics. What are your future plans how are you going to extend, and what activities are you going to include in your Pi wars?
So we are going to try our best to do it this year as close to last year as well, but you know, the virus might really prohibit. So we had the idea to make the workshop online. So maybe we would do that, but we didn't decide to make the competition.
Okay, and how would you like to convert your lab to Fab Lab? I mean, like, this is you are seeking right now actively?
Yeah, like we looked at the requirements. It said like it had like a few required tools, and we have all of them. We have the CNC machine, laser cutter parts, 3D printers. But I think like the 3 official foundation Fab Labs have to approve our Fab Lab, and there is no like a Fab Lab that can approve a new Fab Lab in Turkey. So we have to get in touch with them,
Okay.
make a tour or
Okay, some connection problem it seems. Hello?
can you hear me?
Yeah, can I say it again? What were you saying? What was you saying?
Yeah, we have all the like necessary equipment to become a Fab Lab, but like we need the approval of 3 official foundation Fab Labs, I think, and there is no Fab Lab that can approve us in Turkey. So we have to get in touch with people outside of Turkey and like show our workshop to them. That's probably the largest challenge we have about becoming a Fab Lab.
Okay, so I have talked to people in Fab Foundation, and I am forwarding an email ID to you. You guys can contact them for your queries. They should be able to help you. I have already told them about you. I'll tell them more about you. And you can contact them and get all the information of how to sort of convert it to Fab Lab.
Okay, thank you.
I have posted that on your on the chat, so
okay.
You can contact Rebecca.
Thank you.
Thank you. And this is our contact information, by the way. So if anybody watching wants to like follow what we are doing, they can follow us from Instagram, Twitter, or our websites. And this github.io website, you can find all the necessary like STL files for printing the design and the library, and some of the votes that were made in the PyWars competition. So if you want to take a screenshot, or you can find it on YouTube as well.
Wonderful. Best wishes to you guys.
Thank you. You too.
Thank you.
Thank you. Another question or any feedback? Okay, I think we have done.
Yeah. Positive or negative feedback would be greatly appreciated.
there is I mean there is a lot of effort that you have given. I really liked that you did it for a lot of people. That is more important, that whatever the learning is, whatever kind the project is, if you are sharing it with a lot of people all together and you are making them participate, that is really the key. I really wish and hope that you guys come up with more and more projects and around the theme. And you are mainly using Raspberry Pi, so you can try to use other platforms as well and experiment with more 3D printed design or more challenges. So best wishes for you all. Thank you.
Thank you.
Okay, I think we finish our workshop, right?
We're really happy to be able to host this important workshop, and we thank Fabex and all of you for your participation.
Thank you. Bye.
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 Thank you all.
Bye, everyone.